Standard normal distribution. Now what that is, that's just another fancy way of saying a bell-shaped curve. Now the thing about the bell-shaped curve is, in the middle we have the mean. So I'm going to use that symbol for the mean. And then if it's greater than the mean, it's going to be to the right. And if it's less than the mean, it's going to be to the left. Later on, we're going to be talking about a standard normal curve. Now what that is, it's the same thing, except we have, instead of a mu, we have a z. We'll talk about the z later on. But I want to get you the idea of what's going on when we first start with this. And so these are examples of density curves. Density curves pretty much just means we're looking at a probability distribution, continuous probability distribution. There's no breaks in it. The total area under the curve is exactly 1. So if I were like either one of these and actually find the area of the whole curve, of all the area underneath the curve, it would be 1 every time. The way that's actually found is, I'm using this bell-shaped curve, you actually can draw rectangles underneath, and as you draw your rectangles, you'll notice there'll be some gaps in there. And so later on, I'm going to explain to you why, or what's going on, and talk about these gaps. But before we get to that one, we talk about uniform distribution curve. What a uniform distribution curve is, it actually looks like a rectangle, because it's uniform, it's consistent, it's the same all the way across. Once again, it's got an area of 1. And I'm going to use this formula, area equals height times width, to help us find some probabilities. Now this is going to be the width, as it normally would be. And then this is the height, or you can think of it as the length. But this is very similar to area equals length times width, but we're just going to use h times width. And so let's look at an example to see what's going on. Weight loss varies between 6 pounds and 12 pounds. And it's spread evenly, which means there's a uniform distribution. So I'm going to draw a picture, rectangle, on a horizontal axis, and it's going to be from 6 to 12. So that means that the width is 6 pounds, or 6. And so I need to find the height. And so what I need to do to find the height, I'm going to use a equals height times the width. And so we know that the area of the curve is 1, and then we know the width is 6, and we're going to keep h as h. And so that becomes 1 equals 6h, and divide both sides by 6, we get h is equal to 1/6. Now that's actually a really big deal, because when we find the probability of more than 10 pounds, or more than 10, we're going to use, let me erase that and let me write a little bit better. We're going to use the h times width again, or height times the width, h times w. And the height is 1/6. Well, what's the width? Well, more than 10, if I put it like right there, 10, it's going to be that rectangle right there. So it's not the whole rectangle, it's just a portion of it. So from 10 to 12, the width is semi-circle, 12 minus 10, which is 2. So if you multiply straight across, you get, well, I'd actually did an answer in my head first. I tried to. I got mixed up. It's going to be 2 over 6, which reduces down to 1/3. That's the probability, 1/3. So if you ever see uniform distribution, think of rectangles. And now we're going to go back to normal distribution. And what's going on of a regular normal distribution, we'll use the mean and the standard deviation at the given situation. So later in my video, we're going to do examples involving that. What we're going to do is focus on the standard normal distribution. And what that involves z's. And it involves a mean of 0 and a standard deviation of 1. And what we're going to use is this distribution table. And it's a big deal, but notice that on this table we have a z in the top left corner. So what we're doing is we're using this table to represent all possibilities in life. Got that? And so there will be a conversion factor we're going to use later on. And you may have already seen it, and I'll go ahead and write it for you, just so you can see it. The conversion factor is z equals, I thought I fixed that. I didn't, apparently. It really upsets me in the worst way. It's going to be z equals x minus the mean divided by the standard deviation. And that does convert all real life examples into a z-score. That's what's called a z-score. And then we can use the table. So these first examples, by the way, before I go on, that table does involve the area under the curve, and it also refers to proportions, percents, probability. So if it's asking those questions, these are all done the same way. So here we go. And the key thing is about the table, it does give us the area to the left. And you can see that on the table up here. Area from the left or area to the left, however you want to read it. There's a picture for you also. So these are z-scores with area to the left. Now something I want you to be aware of. If you remember the empirical rule, we got 3 and -3, because these represent the numbers. Z represents the number of standard deviations that data values from the mean. So in the middle is z equals 0. And if you got to 3 or -3, to the area in between, that's roughly 99.7% of the whole curve based on the empirical rule. That's why if you were to look at, let me blow this up a little bit. That's why if you were to look at like -3.0, up there to 0, you see it's a really small value because it's just a little bit of the area under the curve. There's a second part of this table, which is 3.0, and that's roughly, that's 0.9987, so 99.87% of the curve. Which this is more exact than what the empirical rule gives. And so, it is a big deal. Maybe it is the empirical rule. I think 99.7%. And so, in other words, it's almost the whole curve. I'll take that back. It is 99.7% of the whole curve, or in between -3 and 3. That's what the empirical rule is. Between -3 and 3. The 3 represents the area all the way to the left, which includes this region that we didn't account for in the empirical rule. That's why it's actually 0.9987. But what I'm trying to get you to see is it's most of the curve. So that is a big deal. And so the hardest part is actually recognizing how to use the table, start finding table values. So anytime I use TV, I'm referring to table value. So for 2.45, here's what we're going to do. Notice up here we have our z, and here we have the ones place, and then the tens place, and up here we have the hundreds place. So hundreds place. And so the number we're looking at is 2.45. I'm going to decrease this just a little bit. Just put the table in here. I'll decrease it even more so you can see everything. And I'll blow it back up once we find the table value. But 2.45 is what we're looking for. And over here, we find the 2.4. And then to get the 5, if you take a look at this, you know your math with decimals, 2.45 something is 2.4 plus 0.05. So here's 2.4, and 0.05 is going to be up here. So what we're going to do is is find where these two intersect. And they intersect at that value. So maybe go that. Blow up some more. And so that value is the answer. Look, this looks like it's 0.9929. And so that's going to be our table value. I'm going to do that. So 0.9929. Let's go ahead and do negative 0.08. So let's go back to the table. Notice there's negative 0.08. So what we're going to do, we're going to go to the negative 0.0, which is right here. And then the 0.8 is up here, or 0.08. So we need to go, it's the second from the right. So down, or go over, and then it's that number right there, which looks like it's 0.4681. 0.4681. 0.4681. Now let's draw some pictures, see if this makes any sense. Remember what I said about negative 3 and 3? This is really close to 3, so it's going to be way over here. These table values always get the area to the left. So if I were to shade to the left, does it not look like it's going to be about 99% of the curve? And then try negative 0.08. Remember, 0 is in the middle. Negative 0.08 somewhere's over here, just to the left of it. And so, once again, the area to the left, which is going to be a little bit less than half. Half is 50%. And so 0.468 is a little bit less than 50% if you convert it to a percent by moving the decimal 2 places to the right. And so there you go. I always draw pictures for it to make sense. Now what I'm going to do is I'm going to show you a couple other ways to do this. One way is with a calculator. Graphing calculator TI-84 is what I'm using. Let's look at this, 2.45. Now I'm looking at the curve, so to do that, I'm looking for the area. So if you go to second vars, which is right there, you'll see something called normal CDF, which is 2. And then all you do is you do a lower bound and an upper bound, and I think I have this on my notes somewhere. And there it is. And so what I'm going to do is to show you that all you have to do, left bound, use a really small number, like negative 1000 is what I use. Comma, right bound, look at the shaded region, so it goes forever to the left, negative, and it comes to 2.45. Now if this were a real life example or real life numbers, not just z values, then I may have to use something else besides negative 1000. And normally I would put in the mean and standard deviation, but since it's the standard, because it's already converted to z's, I don't need to put that in, and just click here. You'll see the 0.2292. That's the same thing with the negative 0.08. Second vars 2 goes forever to the left, negative 1000, comma, and then it comes to negative 0.08. Close it, hit enter, and you'll see the 0.4681. See that? However, I'm going to show you an even better way. And that even better way is called Statcrunch. Watch this. If you have access to Statcrunch like I do, this is going to be wonderful. So let's go to Stat and then go to Calculator and go to Normal. And you actually see a picture pop up. This is a wonderful picture, by the way. You have no idea what I'm about to show you. How great this is. Let me see if I can make it a little bit bigger, if I can drag it a little bit. Oh yeah. So it should be a little bit easier to see. Let's make it even bigger. Oh yeah. Make it a little bit bigger. I feel like I'm Bob Ross sometimes. And so, it's your world. I'm just living in it. Let's look at 2.45. Now remember, table values is less than 2.45. So, let's go into Statcrunch. And we want the area. Because area left. Notice the mean standard deviation of 0 and 1. We're looking at the z-score, so don't change those. We want it less than 2.451 because or 2.45 because when you're looking for the table value of 2.45, table values always give you the area to the left. So I'm going to keep it like that and then just type in a 2.45 where we have that value. And so I'm going to type it in. Hit enter. What do you see? You see the same curve I drew, so the better. And see the table value 2.2292. It's right there when you round off correctly. Let's do it again with the negative 0.08. Just need to go there. Negative 0.08. Just hit enter. You see the same thing I drew. So if this is better looking. And 0.4681 is the same value we have there. Not shabby at all. Not too bad. You use the word shabby anymore. I don't know if anybody does. Okay. I'm just going to keep it there because I'm going to come back to it later on. So let's go to some more examples. This time we have some symbols. Less than doesn't mean to the left. Greater than means to the right. You see this Z? It's in between those two. So what I'm going to do first is I'm going to draw a picture. I'm feeling more and more like Bob Ross every day. So 1.48, let's draw a picture. Oh yeah. 1.48. Less than to the left. Yeah, I'm going to shade it in. Yeah. And so we can use our table. Just go to 1.48. There's 1.4. We'll go all the way over. And there's the 8. So 0.9306 is the table value. I'm always putting table values first. And I already forgot what it was. 1.9306. Thank you for reminding me. Nope, it did it again. Oops. Now I'm Britney Spears. 0.9306. Now you gotta ask yourself, is that the answer? Yes, because table values give you area to the left, and the z-score is the less than, which is left. So that means that does equal the area that we're looking for. Now let's do this one to the right. Let's draw a picture. 3.14 is going to be way over here. I'll put a z there. That's fine. Z equals. Notice that's to the right because it's greater than. So it's going to be that little bit of area there. So what I'm going to do is I'm going to look up the table value at 3.14. .10123.4, so it's 0.9992. 0.9992. Is there any way that 0.9992, which is over 99%, is going to be that little portion right there? Of course not, because table values are always area to the left. So what that represents is the area to the left. But we want this area. So how you can find the area? Well, we're gonna have to get rid of all of this, exit all out, away from the whole curve, because when we do that, it's gonna leave just this portion right here. Since the area of the whole curve is 1, we're gonna subtract off that 0.9992. And when you do that, you get 0.0008. Now, something about the curve I may not have mentioned. The curve is actually symmetrical. So let me erase that line. Let me erase that. What I mean by symmetrical is z equals 0 is in the middle. So this right side area is the same as this left side area, which means that this tail over here the same as this tail over here, have the same area from the same point, 3.14. This would be negative 3.14. So what you could do is you could go to the table of the negative 3.14 and see what happens. Negative 3.14 is right there, which is 0.008. So that's a little trick or a way to check it. It's not really a trick, but it's a good way to check it. And then we have an in-betweener. So on an in-betweeners, what we're going to do is we need to find two different table values. So for negative 1.09, and by the way, I'll draw a picture here in a second. Let's go ahead and find the table values. Negative 1.09, negative 1.0, and the 9's all the way on the end. 0.1379, 0.1379, 0.1379, 0.1379, and then 0.88 is going to be back on the positive side. 0.88, 0.8, and then the 8's over here. 0.8106, 0.8106. Now let's just draw a picture. That's what we have here. So negative 1.09 is way over here, and 0.88 is over here. We want the area in between. Well, what's going on is this 0.8106 is the area from there all the way to the left. So that's 0.8106. And then from there all the way to the left is this 0.1379. We want the area in between, which means we need to get rid of that, which means we need to get rid of that, which means to find the area, you subtract the bigger minus the smaller, or the right minus the left. Nothing says you can't use a calculator to make sure, so let's use a calculator. So let's clear that out. So we'll have to look at all that. 0.8106 minus 0.1379. That's what that is. And when we subtract those, we get 0.6727. Hey, best have my calculator here. By the way, before I do that, to summarize, if you're using z values, if it's less than, it's just a table value. If it's greater than, it's 1 minus the table value. And if it's the in-betweener, you find each table value and then you subtract right minus left or bigger minus smaller. Big minus small is probably the best way to think of it. But since I have a graphing calculator, let's just use a normal CDF, which is found under second bars. 2, left bound is way over there, negative 1,000, comma, z-score is 1.48. Then you close it. And looky there. Look at that. Would you look at that? A negative point or positive 0.9306. The area should never be negative because you can't have a negative area or negative probability. Let's look at greater than. This one's a little bit different. The other one I just did was just like the ones I've been doing, but this one's a little bit different. This time, notice the shade region. The left is the z-score, 3.14. Comma, how far right does it go? Forever. So let's use a really big number like 1,000 and enter. Now I'm glad I did this because a lot of your calculators will show this like mine did. So what I'm going to do is to show you what's going on. So we see an 8.4. The e of negative 4 is scientific notation, which means negative means you go make it smaller, which means you go to the left 4 places. 1, 2, 3, 4. Throw in zeros for the missing places and notice 0.0008 is the same thing we got. So it is the same thing, just scientific notation. And then the last one, which is the hardest one to do by hand because it has 2 table values, is actually the easiest one to do by graphing calculator. So second vars 2, left bound, right bound, negative 1.09, comma, the right Z value, 0.88, and hit enter, and there's your answer, 0.6727. An even better way is Statcrunch. So less than 1.48, that's already at less than. So let's change it to 1.48. You'll see 0.9306, which is what we got there. Greater than, this is why Statcrunch is way better. Greater than 3.14, because you can change that to greater than. And you already see the area over here, which is the area we shade at. 3.14 was the number we used. And you see that 0.0008? Wonderful. And the last one, between negative 1.09 and 0.88. Keyword there is between. See up here, we have a between. So all I have to do is change those numbers, negative 1.09 and 0.88, negative 1.09 and then 0.88. I just tabbed, by the way. Things are going crazy over here. I gotta make sure I get the numbers in correctly. So negative 1.09 and 0.88 and hit enter. 0.6727. Do you see that? And you'll see the same thing I have there and the same, almost same picture. My pictures are terrible. But hey, I am not Bob Ross. So look at that. Not bad at all. So what you do is totally up to you. It does not make a difference to me. And so this once again is summary by hand, and this is from Calculator, and then I just showed you Statcrunch. So let's do these. I like to use the word so quite a bit. And how you do these is totally up to you. I'm really tempted just to go ahead and use Statcrunch or the graphing calculator just to save some time. You can do it by hand if you want to. I'm going to do some of these. I'm going to just do a variety of. Like this negative 1.45. I'm going to use Statcrunch because it doesn't matter which way we do, so they're all easy. So standard, change that to less than, and change that to 1.45. Just hit enter, and what do you see there? 0.9265. 0.9265. And if you want to look at the table quickly, because I'm sure a lot of people will. 4.5, 1.4, and then the 5 is right there, 0.9265. Greater than negative 1.37. I'm going to draw a picture. A lot of times with the pictures, especially the greater than, it makes life a little bit easier to understand. Negative 1.37 is way over here. Greater than is to the right. And so, if you are a table user, negative 1.37, negative 1.37, let me go up more. Okay, goes off screen. So negative 1.37, 0, 1, 2, 3, 4, 5, 6, 7, 0.0853, 0.0853, 0.0853, 0.0853 is the table value, which there's no way it's going to represent that area because it represents to the left. So if on the area, you do 1 minus 0.0853. And take out your calculator if you want to, and just type that in. I do that a lot. 0.0853. And you'll see 0.9147. If you are using a graphing calculator, second vars 2, it goes from negative 1.37 comma to a really big number. Enter. 0.9147. But my favorite one once again is Statcrunch because it does have a greater than. Negative 1.37. The beauty of Statcrunch draws the picture. That's what I thought too. 0.9147 if you round off. In betweener, you can draw the pictures, find your two table values, and then subtract the two. If you want to do it by hand, but for my sake, I'm going to just use a graphing calculator and then use Statcrunch right quickly. Oh, wrong one. It's not stat, it's above the vars, second vars. 2, and then 1.25, comma 2.31. Notice I didn't even draw a picture because I know the algebra behind it. 0.0952. If you want to see a picture, 1.25 is over here, and 2.31 is close. Shade in between, not much area. That's why it's a small number. I use Statcrunch, which I do. 1.25, 2.31. Go in between. 1.95. Help. 2.21. There. I messed up. Oh, it's 1.25. See? Make sure you use the right numbers. Enter. 0.92 or 0.0952. Is that what I have? 0.0952. Yeah. See that beautiful picture. Now this last one, be extremely careful how you do this one. Draw the picture. No matter what you do, if you use Statcrunch or graphing calculator, it will not give you the complete answer. That's why you need to draw a picture. So negative 2.5 is way over here, and that's less than. And then or means to add. So greater than 2.5 is way over here. So we need these two areas. So what I would do is I would use table value of negative 2.5. Negative 2.5, which is that value right there, 0.0062. Which does represent that area, but since this curve is symmetrical, it also represents that area. So to find the area, crazy things going on. To find the area, you take the 0.0062 and add it to itself, or just times it by 2, however you want to do it. And you should get 0.0134 when you add those two together. Hey, let's find out. 0.00. Oh, I did it again. Oops. 0.0. Oop, I did it. Oops. 0.0062. And just to show you can time 2 or add them together. Oop, I missed it. It happens. It isn't the first time. Won't be the last time. 0.0124. And you can also use calculator or Statcrunch to find one of these. Either one doesn't matter, but only find one of them, and then you still got to do this. Now, these examples are actually going to be backwards. We're going to find the z-score. Different. We're not finding the area, probability, proportion. We're going to find the actual z-score. So I'm going to definitely use a picture to help me out with this. For which the table value is 0.96. Remember, table values represent area. To the left of the z-squared. So if it says 0.96, it's going to be way over here. And it's called this area. So automatically, it can't be that one because negative is way over here. So in that 0.96, I actually drew it wrong. I should never draw it there because that's where z-scores go. I'm going to draw it up here. That's this area. We need to find this z. So what you can do is, it's a backwards question. You want to find the 0.9600 in 4 places. Go to your table, look for the 0.9600 here. which is going to be the positive side. So 0.9600. We're not going to find it exactly, but we're going to get really close to it, which is that value right there, which is 1.701235. So let's see if 1.75 is an answer or a choice. And there it is. The answer is A. Now you can use your graphing calculator also, because it has an inverse norm key. And so we're looking at negative, or at 0.96 is the area. So if you go to second vars, inverse norm is 3. Now normally what you do is you would do the area, comma, mean, comma, standard deviation, but since this is a z-score, and we're already given the table value, it's actually, since we're given the table value, we really don't have to put in the mean standard deviation. We just type in the 0.96, the area in other words, and just hit enter. 1.75. By the way, you may have noticed that it has more values to it. That's because on this normal curve, these areas are just approximations. They're not exact. That's the rectangles I was drawing earlier. These are not exact values. These are approximations. Some books use more digits, some use fewer. This one uses 4. Most use 4. So just be aware of that. You can also do this on Statcrunch. Why not? So here's how you do it on Statcrunch. We're doing 0.96, and this is the area. Area is the same thing as probability. Keep that in mind. So this is telling you that the probability is 0.96. So I'm going to go over here. I'm going to go to the standard. This probability, this value right there, is going to change because we're given that value. That's 0.96, and we need this one to change to less than, because it was looking for the z-score for the area to the left, or for the table value. The table value is always the area to the left, 0.96. Then I click compute, which I already did, and you'll see the 1.75, which is the same thing the graphing calculator gave me, which is the same thing the table gave me. Catch that? Big deal. So this question is actually the same thing as that question, but this one uses the words to the left. So 0.091 is going to be way down here, which is only a small portion of the graph. So 0.0901 is the area for the z-score. So it's a really small area. So it's, these are all negative, so I can't eliminate any of them just as they are. So what I can do is I can go to my table and look for a table value at 0.0901, not a z-score, a table value, 0.0901. So let's go back on the negative side because that's where the small values are. 0.0901 is right there. So 0.0901. I can change the color of my highlighter. It's right there, and that comes from negative 2.3. Oh, that's not the right one. That's 0091. I want 0.0901. So let's keep on looking. Okay, watch these numbers. 0.0901. Where's it at? Oh, there it is. 0.0901 is right there. So that's going to be negative 1.301234. Negative 1.34. Negative 1.34. Which is right there. Did you catch that? This example is for down here. You can also use your graphing calculator. Go to inverse norm, second vars 3, area to the left is 0.0901, and hit enter. Negative 1.34. You can also go to Statcrunch, 0.0901. See, negative 1.34 there also. Statcrunch. Wonderful. I'm telling you it is. Now this one and this one are almost the same. So I'm going to do one of them with the table, and then I'm going to do the other one with the graphing calculator and Statcrunch. So let's do this first one with the table. I'm going to draw the picture. That's what I do. Pictures. This time the area to the right is given. The area to the right is 0.0735, so it's going to be way over here, because the area to the right is a really small area. Really small. So there's a z-score we're looking for. Table values, or the the area of the table, or the table value. Is 0.0735. That's just horrible handwriting. Have you noticed that? I guess because these videos are long enough as it is, I'm trying to make them shorter. So that's 0.0735. So I want to shade that in. So if I use a table, which I am, I cannot find this, because the table always gives us area to the left. So what that means is that the area is not actually a table value for this one yet, because the area or the table value is giving me area to the left. So what that means is I need this area. Remember, I'm looking for the z-score, so that the area is 0.0735, which is the same thing as saying the area that's to the left of the z-score. But how do I get that area? That area is found by finding 1 minus 0.0735. So let's just type in 1 minus 0.0735. 0.9265. This is the table value that I need. Got that? Table gives us area to the left. This is an area to the right, which means that I need the area to the left, which is found by finding 1 minus the area to the right, which is 0.9265. So let's go to my curve. 0.9265 is going to be the positive side. 0.9265 is right there, which is 1.401234.5. 1.45, which is a. In fact, I'm going to go ahead and do this on the calculator, because this one's, you really need to see it. Once again, inverse vars, number 3. Now I could just type in the point, or the 0.9265, but I could just type in 1 minus 0.0735, since it's the area to the right. I know it's going to be 1 minus, and then hit enter. It does it for me. So I don't have to do any work anywhere else. 1.45. And also on Statcrunch. Statcrunch is the greatest thing ever, because of Statcrunch, notice its area to the right is 0.0735. 0.0735. 0.0735. But it's greater than, because I can take that and move it, make it greater than. Now, do you see the area? This is why Statcrunch is so great. And then compute. Well, I don't have to compute, because they already did it for me. 1.45. But do you see that? See how great that is? Let me say that again. You see how great that is? It's just great. It's so great that I'm going to do the next one with Statcrunch only. I would also do it with a calculator. I'm not going to do it by hand. I'm just going to draw a picture. 0.86 to the right. Which means it's going to be a large percentage of the graph. Call it right there. So all this is 0.86. Statcrunch is so great. Let's just use it. 0.86 to the right. I've already got greater than there, so I need to change that to 0.86. Just hit enter. Looky there. The reason why I have to draw the graphs is because if I use Statcrunch, it should correspond closely with what I have. So the answer is negative 1.08, which is B. You can also use your graphing calculator if you want to. Do it the same way we just did that one. That's on my screen. Second bars, 3, 1 minus 0.86. I didn't do 1 minus. Negative 1.08. If you do it by hand, 1 minus 0.86 is 0.14. So if you look at the table value for 0.14, or the table value that is 0.14, I should say. Where is it at? I'm not looking in the right place. Oh, there it is. Negative 1.0. 0, 1, 2, 3, 4, 5, 6, 7, 8. That's the one we have. Negative 1.08. Same thing. But Statcrunch and the graphing calculator are actually more accurate.